Welcome everybody. In this video, I want to do some more examples on rationalizing denominators, but I brought in some examples here that have variables in them. So a lot of the examples in the previous video are just numbers, right? So here we're going to do some with variables as well. If you see something obvious that you can simplify first, you may want to go ahead and do that. So for instance, notice how I have a root 16 here, which would be 4. So this becomes just 2 root 4 on the top. And in the bottom, I have that root 9, and that's a perfect square also. So I can take that out as a 3, and then I just have a root x left in the denominator. So I have 8 over 3 root x. Again, and that's what I would recommend is, try to simplify a little bit first, so it just makes it easier. Now, I do want to get rid of that root. So when you have a square root, and again, there's no adding or subtracting here. That's key. So just a really more basic fraction. For square roots, what you're going to do is just multiply by whatever that root is on top and bottom. The reason we do that is because when you multiply these together, on the inside, you have x times x, which is x squared. And now you're able to go ahead and cancel that radical out. So you're left with 8 root x over 3x. Now here, again, I'm going to assume that all my my variables are positive, so I'm going to leave it like this. If you were not sure, though, you would put those absolute value signs around your x as well, but we're just going to go ahead and leave that as it is. For the next example, the first thing I'm going to do before I start is I am going to split this because I don't really know what my denominator is, right? It's kind of all combined together under the radical. So I want to make sure I have a distinct denominator that has its own radical. So I have this here. Now, I can't do any simplifying, right? 7/3 doesn't simplify. 7 is not a perfect square, neither is 3. So there's really nothing I can do here. So I'm going to go ahead and jump in. Again, if I just have a square root, and there's no plus or minus, I'm going to repeat whatever that radical is from the denominator and multiply it through by on the top and the bottom. When I do that, 7 times 3 is 21, x times y is xy. In the bottom, 3 times 3 is 9, and y times y is y squared. So I'm able to, at the very least, clear out the bottom. Root 9 is 3, and then don't forget that square and square root are going to cancel. I'm going to assume my values here are non-negative, so it would just be that 3y there. And that's all we can do. So our goal with rationalizing the denominator is to not have any roots in the denominator. That's it. So again, our goal is to get rid of the roots in the denominator when we rationalize them. And it's just a preferred form to write our final answers in. It's sort of like simplifying your fractions. Okay. Now, the next one here, we have a 4th root. Again, if there's something that you can see that is obvious that you can clear out, I would recommend doing that first. I think it just makes it, that much easier. Now, with the numerator, there's nothing I can really do there. So I'm just going to leave it as the 4th root of x for now. But in the denominator, that 4th root of 81, I actually can clear out. It's the value 3. 3 to the 4th power is 81. So that becomes 3. Now with the y, it's a little bit more complicated. 5 divided by 4 does not work out evenly, so it's not going to be an easy one. But I can split that y to the 5 as y to the 4 times y. Remember, when we're simplifying more complicated roots like this, our goal is to try to clear out as much as we can. 4 plus 1 is still 5, so I haven't changed this here. But if I have a 4, I'm able to cancel it with this 4. So the 4th root of y to the 4th times the 4th root of y, this piece gets to cancel out. And now I just have a at least somewhat easier denominator to deal with here. Now with higher power radicals, so cubed roots, 4th roots, 5th roots, etc., you're not just repeating what's there. You actually have to think about it a little bit more. So I have a 4th root here, so I'm going to do the 4th root of something. And I want to get this to cancel, right? So I want my root to go away. That's my goal here. So for it to go away, I would need to have a y to the 4th. If I had a y to the 4th, then I could get those to cancel. Well, right now I only have a y, so I would need 3 more y's to get it to cancel. So that's what I'm going to multiply by here. So when you have a higher power like a cube or a fourth or a fifth, you really have to think about, well, what would I need to multiply by to get this to cancel? So in this case, we'd have to multiply by the y cubed. And it is very tricky to think about factors, and it's a little bit of trial and error to get it to work. So once I do that, in the numerator, I have the fourth root of xy cubed. I have a 3y in the denominator, and now I am able to have that fourth root of y to the fourth and get that to cancel. So I have a 3y times another y from here. And finally, in the denominator, then, I'm left with 3y squared. Okay, so let's do one more example here. All right. Now this one's a little bit more complicated. I'm going back to the square roots, but I have a plus sign in the bottom. So remember here that we're going to use a conjugate. So we're going to use the same thing in the denominator because it's a square root, but we're going to change the sign from plus to minus, and that will give us a nice canceling effect here. Keep in mind there is another video as well on rationalizing denominators. So if you missed that one, you may want to go back to the simpler examples first. So when you have square roots and you have addition or subtraction, what you're going to do is use exactly what's in the bottom, oh, because we're doing the denominators here, and instead you just change that sign. So instead of having a plus, we're going to go to minus. And the only thing here is you are going to have to do some distributing or FOILing out here. So in the top, I'm going to multiply the 2 root m to both pieces. I'm going to write this out for myself because it's pretty confusing. And then the bottom, I'm going to do the same thing, but I'm going to have to distribute a bit, right? So I'm going to take that 3 root x first to both pieces, and then I'm going to take that root m to both pieces. So I'm FOILing out, or I'm doing a double distribution here. So I have 3 root x times 3 root x, 3 root x times negative root m, right? Multiplying that one through. Now I'm going to switch here. Positive root m times 3 root x, and then positive root m times negative root m, running out of room for that last piece. When you're multiplying, remember that outside things stay together, inside the root things stay together. So in the top, I have 2 times 3 is 6, and then I have an mx underneath, minus 2, and then I have an m squared. In the bottom, 3 times 3 is 9, x times x is x squared. Next, I have a negative 3 root xm. Here I have a positive 3 root xm. And again, you could write it as mx or xm. It doesn't matter. Here I have a minus m times m is m squared. Now I'm going to keep simplifying this. So I have a 6 root mx. Here, though, and again, I'm going to assume everything is non-negative, I should say. I'm going to cancel that square and root. So this becomes just 2m. In the bottom, the same thing, that square and root are going to cancel. So this becomes 9x. Notice that these are like radicals, so I can combine them together, but negative 3 plus 3 is 0. So this is going to cancel itself out. And then the root and the square here are also going to cancel. So I have a minus m. Now, remember the goal of rationalizing that denominator is really so that there's just no root in the denominator. It doesn't mean that it's going to look super nice always. It just means that there's no more radical in that denominator. So this is as good as it's going to get. I can't really simplify anything else or combine any more like terms here. So we are done.